So we're going to look at this limit. When we look at x approaching 2 from the right, we're going to be looking at numbers kind of like 2.1. So if I were to plug in 2.1 into our problem, or 2 minus 5, it gives us negative 3, so we're looking at a little bit less than negative 3, but overall the top part here is negative. This bottom part, we have 2 minus 2, but it's about like 2 point something, so it's a little bit more than 2, so the bottom would be going to be a positive number, because this is a 0 that's going to be in the denominator and not 0 over 0. What I am going to notice is that it is going to be going towards negative infinity. So negative infinity or does not exist are appropriate answers here. If we look at this one as x approaches negative 3 from the left, if I were to plug in 3, we are going to be getting 9, negative 9 plus 10 to give me 1. So when I am looking at the top here, this is going to give me a positive value. On the other hand, when I look at negative 3 from the left, that's like negative 3.1, so slightly more than 3. So when I add them together, our denominator is going to be slightly negative. So we are looking at negative infinity here again. So negative infinity does not exist are kind of the answers we're looking for. So determine which function below below have a vertical asymptote based on the limit statements. So just keeping in mind when we're talking about this, we want to look for things that have us going towards infinity for our y value. So if I look at this first one, the limit as x approaches 3 of f of x is equal to 0. This is giving us a specific x and y value. So this does not tell me that we have a vertical asymptote. We could have a hole there, but we don't know for sure. It could just be a solid point. So it's not a vertical asymptote. This one, as x approaches 2 of g of x is equal to infinity. This one does have a vertical asymptote, and it specifically has a vertical asymptote at our x value. So at x equals 2. When we're looking here, the limit as x approaches negative 5 from the right side is equal to infinity. This absolutely means we have a vertical asymptote because we are going towards an infinity, and our x value is a specific number. So we have a vertical asymptote at x equals negative 5. Just because it is on one side, it doesn't mean the other side has to be as well. We could have some really weird piecewise function graph, but we know for sure there's a vertical asymptote because we get that infinity for a y value. This last one, we have the limit as x approaches infinity of k of x is equal to negative 4. Because our x value is going to infinity and it's not our y value, this is not a vertical asymptote. This would be something in reference to end behavior, which is what we're going to be talking about next with horizontal asymptotes.